Welcome back to the deep dive. Today we are doing a really specialized one.
Yeah, this is for a very specific person.
It is. If you're someone who's, been steadily improving your brewing skills, you're learning about green coffee, and you feel like you're ready to move past being just a curious novice.
Right, ready to master the roast itself.
Exactly. This deep dive is for you. We are getting into the weeds on some high-tech equipment that's really designed to bridge that exact gap.
That's the key, that transition point.
Yeah.
We've been looking at all the sources on the Kaleido Sniper series of roasters. And our goal isn't, just to read you a feature list.
Yeah.
We want to explain the engineering behind it. Why these machines can function at a near professional level right in your home.
So let's set the stage then. What's the core idea here? Because a lot of home user equipment, it kind of waters down the real capability for the sake of simplicity.
And that's the difference. The mission statement for the Kaleido Sniper seems to be all about empowerment. It's designed to enhance the whole experience by basically removing the technical hurdles.
The barriers to entry.
Exactly. The goal is to make the joy of really serious coffee roasting accessible to everyone, whether you've got a huge industrial setup or just, a corner of your kitchen.
And what we found in the material really confirms that this isn't a static thing. They're constantly evolving it.
Right.
Every roaster has been tested, verified, upgraded across generations, but they keep the essential things that worked in the first place, so the promise is pretty robust.
It is. It's basically saying, look, this equipment can help you complete every part of the roasting task so you can achieve that perfect roasting experience.
When the machine handles the consistency, you can focus on the art, the smell, the sound.
That's where the craft is. They're just trying to minimize the variables for you.
Okay, that brings us right to the engine room then. The heat source. This is where a roast lives or dies. So our first section is all about heat and efficiency. Controllable heat, specifically rapid heat, is the difference between a stalled, baked-tasting roast and a really dynamic flavor profile. So how do they do it? How do you get that kind of speed without needing an industrial power line?
This is the core innovation, really. It's the electric carbon fiber infrared heating technology.
Okay.
So traditionally, you've got resistance heating coils or gas burners. The old coils, they heat up slowly, and worse, they hold on to heat. High thermal inertia.
Right, so if you want the temperature to drop fast, the coil is still glowing hot and fighting you.
Precisely. The carbon fiber infrared system completely changes that. And the breakthrough is sort of twofold. One, these elements have an incredibly fast zonal response.
And the second part?
They emit infrared energy that has, and this is the key phrase, a unique penetration performance.
Okay, hold on. Penetration performance, that sounds super technical. What does that actually mean for the coffee bean?
It's a great question. Think of it like sitting by a campfire. The air around you might be cold, but you feel the heat directly on your skin.
I see.
Infrared transfers energy directly to the bean mass without just heating up all the air around it. That penetration means the heat gets delivered efficiently and, deep into the core of the bean.
Which lets you do those really fast temperature ramps, the rate of rise.
Yes, which is crucial for developing those bright, complex, acidic flavors. That's the key.
So that delivery method means you get, for the home user, a really powerful system, but with low energy use. It's efficient.
It lets you create flavor profiles you used to need industrial gear to achieve, but without, rewiring your garage.
Yeah.
You get the speed and the precision without the massive energy bill.
So we've nailed the speed on the way up. But that speed means nothing if you can't stop on a dime.
Right.
Which brings us to the next big problem in home roasting. Stopping the roast. Over-roasting. Once those beans hit your target, you have to cool them. Now.
You've hit the nail on the head. Even a few seconds of what they call thermal carryover, just the heat the bean itself is holding on to, that can push a medium roast into a dark roast and just flatten all those flavors you work so hard for.
And that's where their independent cooling system comes in.
Exactly. Its entire purpose is to prevent that over-roasting.
Okay, but I have to ask.
Yeah.
You've got this super fast cooling system running right next to a heating element, don't they? I don't know, fight each other. Doesn't that mess with your temperature stability for the next batch?
That is a really sharp and very fair question.
Yeah.
And it really speaks to how well this is designed. In a lot of other machines, thermal bleed is a huge problem.
Right.
But the key word here is independent. This system is built with its own air path, its own shielding. It is specifically designed not to affect the heating side of the machine at all.
And they didn't skimp on the hardware. We saw that depending on the model, they have either 2 or 4 dedicated cooling fans.
Yeah, they're not messing around. That power ensures the bean temperature just plummets. But the real game changer here is the workflow.
What do you mean by workflow?
Because the cooling is separate, you can basically dump your finished beans and say, just forget about them.
Ah, so you can immediately start getting the next batch ready.
You can start preheating, weighing, even loading the next batch while the first one is cooling. This is what enables true back-to-back roasting.
Which, for a hobbyist who only has, like, a Sunday afternoon to roast.
It's invaluable. It's the difference between doing 2 batches in an hour and maybe doing 4 or 5. You get consistency and efficiency at the same time. It's huge.
It really moves it from being a stop-and-start process to a smooth, professional rhythm.
That's it. You're controlling every variable but the coffee itself.
Okay, let's shift gears a little. Let's talk about the smaller things, the practical design choices that really add up to precision. We need to talk about the temperature probe.
Yes, the data source.
Anyone who has tried to track a roast knows this problem. The temperature you read is completely different depending on where your probe is. A millimeter makes a huge difference.
That variance.
Yeah.
It's a massive barrier. If you can't trust your measurements, you can't replicate your successes. It's that simple. So the designers here, they focused on the thing that actually holds the probe.
And what's the solution they came up with?
It sounds simple, but it's a screw-free, self-locking probe holder.
Okay.
So when you're roasting, you want that probe pip sitting perfectly in the middle of the bean mass, not touching the drum wall, to get a true bean temp reading.
So it's like trying to check if your chicken is cooked by sticking the thermometer in the oven door instead of deep in the chicken itself.
That is a perfect analogy.
Yeah.
Exactly. Now, with a standard setup, adjusting that can be a real pain. You might need tools, or it might slip over time.
And with this?
The self-locking design means you can just slide the probe to the exact depth you want it, let go, and it locks in place instantly.
So it's about repeatability.
It's all about repeatability without needing to be a mechanical engineer. You set it once, perfectly, and you can trust that your measurement location is identical, batch after batch after batch.
So again, it's about removing another variable.
Precisely.
Yeah.
You stop wondering, is my probe in the right spot? And you start asking, how did that read of rise affect the final taste?
Okay, moving on. Let's wrap up with 2 last crucial things. What's happening inside the drum and what's happening outside with the smoke.
Uniformity and environment, both critical.
Let's start with uniformity. If the beans aren't tumbling correctly, you get scorching on one side and underdevelopment on the other.
Right, and that starts with the drum itself. The sources talked about the flexible drum, which is an enhanced high-speed steel mesh bean drum.
A mesh drum, how is that different from a solid one?
A solid drum relies mostly on conduction, the bean touching the hot metal. A mesh drum dramatically increases convective heat transfer. Exactly. Hot air is circulating way more freely and evenly through the entire bean mass as it tumbles. The main benefit is a truly uniformly heated roast. It minimizes that scorching.
And there's a side benefit to that better movement too, right? Something about housekeeping.
Yes. Chaff separation.
Yeah.
Chaff is that papery skin that flakes off the bean.
Right.
Better movement and more even heat exposure means that chaff separates much more cleanly and completely, which, improves the taste by reducing bitterness, and honestly, it just makes less of a mess inside your machine.
All right, let's talk about the elephant in the room for anyone who's tried this at home.
The smoke.
Smoke, it fills the kitchen, the smoke alarm goes off. It's a whole thing. You can't avoid it, especially on darker roasts.
It's inevitable. And what's interesting here is how pragmatic their 2-part solution is. They seem to recognize the reality of it.
What's the first part?
First, the roaster has a built-in extraction system that's powerful enough to handle most of the smoke from, say, a light to medium roast. For many users, that's probably enough.
But if you're going for a really dark Italian roast or running multiple large batches,
then smoke is still going to happen. You can't beat physics. So that's the second part of their solution.
Yeah.
They designed a special smoke exhaust pipe that just attaches.
So you can just vent it out a window?
Vent it out a window or into an existing hood.
Yeah.
It's smart. They don't promise the impossible. They just give you a simple tool to manage the reality. It gives you control over your environment.
So you can actually push the machine to its limits without smoking out your entire house.
That's the idea.
Okay, so let's just quickly recap the big takeaways here. First, we had the carbon fiber infrared heating, which gives you that incredible speed and control.
With low thermal inertia, so it's responsive.
Then the independent cooling system, which is a massive workflow upgrade, is what makes that back-to-back roasting a real thing.
Without compromising flavor. It's huge.
And finally, those little details that make a big difference, like the self-locking probe holder that makes precise, repeatable data accessible to anyone.
And these aren't just, nice-to-have features. They are fundamental upgrades. By combining rapid heating, instant cooling, and trustworthy measurement, the tech just removes all those frustrating mechanical things that trip up new roasters.
You stop fighting the equipment.
You stop fighting the equipment and you start focusing purely on the craft of developing flavor.
So that brings us to the final thought. If the technology is now handling all of this for you, the speed, the cooling, the data, what does that mean for you, the person listening? What new doors does that open up?
Well, the mechanical barriers are, for the most part, gone. And that frees up all your mental energy to focus on the really complex stuff. The relationship between a bean's origin, its density, and the kind of profile you can create.
So you can start asking different questions.
Totally different questions. Can I try a super fast development on a really dense Ethiopian bean? Can I push a low-density bean right to the edge without baking it? When the machine handles the basics, the only limit really is your own creativity.
A path to mastery that's actually accessible. A phenomenal thought to end on. Thanks for joining us for the deep dive.
My pleasure.
We'll catch you next time.